Video we will try to solve a problem on indirect utility function and how to use Roy's identity. The question is like this: assume a consumer with utility function in the form of, we are being given the utility function of a consumer is x1 into x2 upon x1 plus x2. X1 and x2 are the two goods. Prove that indirect utility function is equal to, that is v is equal to m upon p1 plus p2 plus twice p1 p2. We need to prove this, that the indirect utility function for the consumer will be this very stuff. Use Roy's identity to derive Marshall and demand function of good x1 and x2. We have to use the Roy's identity also to derive the Marshall and demand. Okay, now what we are being given, we are being given the utility function of a consumer. Now to derive the this indirect utility function, first we need to find out the demand functions for good x1 and x2. And to find the demand functions for good x1 and x2, first we need to construct the budget constraint here. Okay, so this is our utility function which is being given. Our budget constraint will be simply equal to price of good 1 into units of good 1 plus price of good 2 into units of good 2 should be equal to total income. This is our utility function, this is our budget constraint. To find the demand function for good x1 and x2, that means we need to maximize this utility function with the given budget constraint. That means I will maximize this utility function subject to this budget constraint. Okay, this budget constraint. How do we do this? Simply we use the tangency condition, that our marginal rate of substitution between two goods x1 and x2 should be equal to, so let me write it here, 1 2. Okay, 1 2 is equal to price of good x upon price of good, price of good 1 and price of good 2, x1 and x2 here. Okay, marginal rate of substitution is nothing but the derivative of, partial derivative of our utility function, or let me write it here, this is simply equal to marginal utility of good x1 upon marginal utility of good x2 should be equal to p1 upon p2. Okay, so I have done here mistake, they can occur here. Now marginal utility of good x1 means partially differentiating our utility function with respect to x1. Okay, so that is simply du1, that means partially differentiating this demand function, this utility function with respect to good x1 upon dx1. Okay, du upon dx1. This is marginal utility function for good x1. Similarly, we have marginal utility for good x2 as du upon dx2 should be equal to p1 upon p2. Okay, so first we need to find out the demand function for good x1 and x2, and then we can find out the indirect utility function. Now what is this du upon dx1? Du upon dx1 means partially differentiating this utility function with respect to x1. Okay, so let me show it, how will I derive it. So du upon dx1 means we have to partially differentiate this utility function with respect to x1. Here we will use the quotient rule. If we are being given f of x and g of x, we have the functions in this form. Okay, to take the derivative of this function, what we do, first we write this g of x, take derivative of the in this function which is f dash x, minus we write f x and take derivative of this gx. Okay, divide by gx whole square. This is the rule which we will use here. So in place of f of x, we have x1 x2 divided by, in place of g of x we have x1 plus x2, x1 plus x2. Okay, now our du upon dx1 will be equal to, so let me write it here, du upon dx1. I am just trying to find out this stuff here. Okay, so first we have this, if this is f of x, this is g of x, then I have to write first this g of x, and g of x is here, this x1 plus x2, so we have x1 plus x2. Okay, take derivative of this function, which is f of x. Now derivative of x1 will be 1, so we are left with x2 only. Okay, then we have minus, we write this f of x, is x1 x2, so we have x1 x2, and take derivative of g of x, so g of x is this, so derivative with respect to x1, derivative of x1 will be 1, so we are left with only 1. Okay, divided by gx square. Okay, so g of x square will be equal to x1 plus x2 whole square. Okay, so let us try to solve this out. So this will become x1 x2 plus, okay, I am just multiplying this x2 to each of these terms, this becomes x2 square minus x1 x2 divided by x1 plus x2 whole square. Okay, so these two terms will get cancelled. We are left with x2 square upon x1 plus x2 square. Okay, so this du upon dx1 is this stuff. Okay, so let me write it here. So du upon dx1 means we have this x2 square divided by x1 plus x2 whole square. Okay, so du upon dx1 is this, divided by, now du upon dx2, again it means we have this utility function. This time we have to use again the quotient rule and take partial derivative with respect to x2. Okay, same stuff we will apply, which we first we write the numerator function, which is x1 plus x2. Okay, and take derivative of first we write the denominator function and take the derivative of numerator function. So derivative with respect to x2 will be 1, so we are left with x1 minus, then we write x1 x2, then numerator x1 x2, and take the derivative of the denominator function with respect to x2. So we have here the derivative of x2 will be 1, so we are left with only 1. The derivative of x1 will be 0 because we are partially differentiating with respect to x2 here. Okay, whole divided by, we have the denominator is x1 plus x2 whole square. Okay, this means du upon dx2. Okay, so we are using just this power function rule here. Now rearranging this, we will get multiplying this x1 into x1 is x1 square plus we have x1 x2 minus x1 x2, then we have x1 plus x2 whole square. Okay, so these two same terms gets cancelled. We are again left with x1 square upon x1 plus x2. So our du upon dx2 is this stuff. So I can just erase this because I don't have the luxury of writing all this stuff here. I'm just doing this manual work here. So du upon dx2 is this stuff, that is x1 square upon x1 plus x2 whole square. So I forgot to write the square here. Okay, I'm just using the power function. Sorry, quotient rule here to differentiate partially our marginal utility of good x1 and marginal utility of good x2. Okay, and this all stuff should be equal to p1 upon p2. Here we can do one thing, we can rearrange this, or simply we can just cancel these two terms. If we are being given 2 upon 3 divided by 1 upon or 7 upon 3, so we can always cancel these two denominators. So here I can cancel this stuff and this stuff, so I will be left with x2 square upon x1 square is equal to p1 upon p2. Okay, so this can be written as x1 upon x2 whole square, okay, is equal to p1 upon p2, which can be written as, let me write it here now, which means I can write x1 upon x2 will be transposing this square, it will become root here like this, p1 upon p2, which implies our, so I have written it opposite way here, so we have x2 upon x1 here. Okay, so we have here x2 upon x1, x2 upon x1 is this, which means x2 will be equal to under root p1 upon p2 into this x1. Okay, transposing this. So let me rub this out here. Now this is x1 is equal to this stuff. Now just plug this value of x2 in our budget constraint, okay, to get the demand function, for good x. Okay, so our ultimate goal is to find out the indirect utility function. To find the indirect utility function, first we need to find out the demand function for good x1 and x2. We got this, x2 is equal to this. Just plug this value in this function. Okay, so we have p1 x1 plus then p2 and in place of x2 I have this very function here, so I can write it like this, p1 upon, in place of this because this under root is for whole, I can write it like this, p2 raised power 1 upon 2, okay, into x1. I have written this with a reason, should be equal to m. Okay, so that means I can write it like this, p1 x1 plus this stuff. Okay, if I am being given p2 divided by p2 raised power 1 upon 2, I can write it like this, p2 into p2. If I transpose this denominator to numerator, it will get multiplied and the product sign, exponent sign will get changed. We have same terms, so we have p2, we have we can add up the exponent, so we have 1 minus 1 upon 2, which will come out to be p2 raised power 1 upon 2, which will be p2 again. Okay, so we are again left with p2. So in place of this, when we solve these two things here, I will get p2. So let me rub this here, so I can write it like this, we have p2 under root p2, these two will give us under root p2, so then we have under root p2 into under root p1, so we can write it like this, p1 p2, basic mathematics. Okay, so in place of this I can write under root p1 p2 should be equal to m. Then what we need to do, That means our x, and obviously we have here x1, which I forgot to write. X1 is equal to m, which gives us, taking x1 common, we are left with p1 plus p1 p2. Okay, it should be equal to m, which gives us x1 is equal to m upon p1 plus p1 p2. This is the demand function for good x1. Now just plug this x1 is equal to in this function, where in this function, to get the demand function for good x2. Okay, so if I plug this value here, so our x2 will be equal to, I have, so let me write it again here. So we have here p1 upon, I can write it like this, p2. Okay, so I can write it like this. So x2 is equal to under root p1 upon under root p2, and x which we got here, which is equal to m upon p1 plus p1 p2. So here we have this m into p1, so I can write it like this, m under root p1 divided by, so multiplying this p2 to each of these terms, so I will get p1 under root p2 plus, so under root p2 we have under root p2 into under root p1 p2. Okay, this can be written like this, p2 into p1 into p2. Okay, so now under root p2 into under root p2 will be p2. How? So if we multiply these two, this will become p2 square under root p1. Okay, square root gets cancelled, so we are left with p2 under root p1. Okay, so in place of this p2 into this stuff, when I multiply this, I will get p2 into p1. Okay, so writing this again, let us take p1 common. If I let me write it here, so m under root p1 divided by, if I take under root p1 common, under root p1 common, so I will be left with under root p1. Okay, and we have under root p2 here, plus I have, if I take this p1 common, so I am left with p2 only. Okay, so this p1 and this p1 will get cancelled, so I will be left with, so let me write it here, so I will be left with m upon p2. Okay, p2 plus, so p1 under root p1 under root p2 can be written as p1 p2. Okay, so this is the demand function for good x2. Okay, let me write it somewhat beautifully. X2 will be equal to m upon p2 plus p1 into p2. This is the demand function for good x, and this is the good demand function for good so this is the demand function for good x2, this is the demand function for good x1. Okay, this, now we need to find out the indirect utility function. By indirect utility function, what we mean, so let me rub this whole stuff here now. Okay, I don't have space, that's why I'm just trying to make the space here. So this was our utility function, what we call the direct utility function. Direct utility function shows our utility which is being derived by the consumption of good x1 and x2. By indirect utility function, we mean that our utility depends upon the price of the two goods and the income of the consumer. Okay, so indirectly our utility depends upon the prices of two goods and the income of the consumer. Okay, and it makes sense. So by direct utility, what we simply say our utility depends upon the consumption of good x1 and x2. Now to consume these two goods x1 and x2, so there will be obviously some price. Okay, also the consumer should have an income. Okay, when we have a function where our utility depends upon good of x uh, prices of the goods and the income, we say that is the indirect utility function. And when the utility, direct utility is simply when our utility depends upon the consumption of goods, two goods. The utility derived from the consumption of the two goods is our direct utility, but indirectly that depends upon the prices of the two goods and the income. That's why we say this is the indirect utility function, where a consumer's indirect utility function is a function of price of goods and the consumer's income. Okay, so I will not go into the detail. I have made earlier video on that also. Now we need to find out the indirect utility function. How can we find the indirect utility function? Let's denote it by v. So indirect utility function will be the function of good prices P1, P2, and the income of the consumer. And how do we find out the indirect utility function? We need to plug out our demand function of good x1 and x2 in our utility function to get the indirect utility function. I repeat here, to find out the indirect utility function, just to plug the optimal values of good x1 and x2 back into our utility function to get the indirect utility function. Okay, so will be equal to, this will be equal to, so x1, we got the value of x1 is m upon p1 plus under root p1 p2 into x2. So x2 is again m upon, this time we have p2 plus under root of p1 p2. So then we have this divided by x1 again, which is m upon p1 plus p1 p2 plus this time then we have x2. So we have again m upon p2 plus p1 p2. So we just need to prove that our indirect utility function will be equal to this stuff. So doing some calculation here, I fear I cannot show the Roy's identity here because the video is getting lengthier and lengthier here. Okay, so let me just wrap up this here. So m into m, we have multiply, we can multiply numerator with numerator and denominator with denominator. So we have m into m is m square, so let me write it here. So we have m square divided by, so we have this function here, p1 p1 plus p1 p2 into again this p2 plus p1 p2. This is the denominator numerator here, whole divided by, again here we have to do the, but here we have to do cross multiplication because we have plus here. So here I can write it like this, m into p2. So we have m upon p2 plus m into p1 p2, okay, multiplying this, then we have plus m p1, okay, plus m, again this p1 into p2, okay. So this whole divided by this stuff, that means p1 plus p1 into p2, then we have p2 plus p1 into p2, okay. I hope I am making myself clear. So these terms will get cancelled, they are same. We are left with, so what should I rub now? So let me rub this stuff here, okay. So we are left with m square, okay, m square divided by m times p2 plus m times under root of p1 p2 plus we have m p1 plus m p1 p2, okay. Solving this, we can take m first common. So if I take, we have m square, taking m common, I am left with p2 plus p1 p2 plus p1 plus p1 p2. M gets cancelled, so we are left with m. So here these are the same terms, I can add them up. So I am left with p1, then I have plus this p2 plus twice, because they are the same terms, I can add them. So this and this is twice this and this, khabar kya, p1 p2. I hope I am making the calculation right. So this is our indirect utility function, okay. So this is our indirect utility function, and it obviously depends upon the prices of the two goods and the income of the consumer, okay. By direct utility function, which is being given us here, so this is our direct utility function, so this is our indirect utility function. So let me write it here. So our indirect utility function is function of p1 p2 and income, and you can see here this depends upon the price of good 1, price of good 2, and the income. And what was our direct utility function? That was x1. Let me write the direct utility function like this: u is a function of x1 and x2, which was being given us as x1 into x2 divided by x1 plus x2, okay. This is our direct utility function. When our utility depends upon the consumption of the two goods, we say it is the direct utility function. And when our utility function depends upon the prices of the two goods and the income of the consumer, okay, this is the indirect utility function. I hope I make myself clear in this video. So azan is going on, I cannot further continue this very video using Roy's identity. It is not suitable to continue this video. It has gone a lengthy little bit, okay. Thank you. For more videos on mathematical economics, please subscribe this channel, like, comment and share also. Thank you.